My name is Ben Montgomery. What I thought we would do is speak about something that is a really, really interesting topic that came about relatively recently, which is kind of what I love about data science. You can start kind of going in one direction, and then you start exploring a problem. And then, the most important thing is kind of understanding what you're looking at. So what we started doing was looking at one problem, and then we quickly realized we could go in a whole different direction with it. So what we're going to look at is navigating the gender pay gap. So if any of you now get up and walk out, I'm totally going to judge you, by the way. I'm just kidding. But essentially what we tried to do here and what we started doing is, before I do that, actually, sorry, I forgot. There was an invitation for all of you, which is to a party, which is thrown by Dataiku and The Guardian. So it's to mark the end of the gender pay gap. So you're all invited, but it's in 2235, sadly. So those are real figures, which is kind of depressing, so I apologize. But the way that we kind of set about this, there's a couple different challenges when you start looking at something as sensitive and as kind of difficult to obtain as a data set looking at the gender pay gap. So I do apologize, you're going to have to look at this guy for a little while I kind of go through the methodology here a bit. But there's two different ways that you can kind of go when you're looking at gender data and analyzing the gender pay gap that you get. The first way is you can look at the adjusted pay gap. The second way is you can look at the unadjusted pay gap. So what does this mean? The adjusted pay gap is you can look at the data and you can adjust it for different factors. So you can basically make an attempt to try and explain the discrepancies that you're seeing in the data. So we kind of looked around and we found different ways that you could kind of account for this. And of course, there's all the familiar arguments like part-time work, the type of occupation could explain some of the reasoning behind it, having and caring for children. There's all kind of different articles and people that have explored these topics. Temporal flexibility is an interesting one, which was written by a female economist, incidentally, in the US. And she argues that women will naturally seek jobs that have more kind of flexibility for going home and looking after kids. I found that a bit of a strange argument, but nonetheless, there's lots of different directions. So we said we're not going to do any of that. We're not going to adjust for any of these factors. What we want to do is take the data as we find it and do an analysis based on that. Now, we kind of wanted to remove all the bias out of it. We're not trying to explain what we're seeing. We're just trying to present the results as we see them. So we looked at the unadjusted pay gap. And a couple of important things here. First of all, the data set that we got is not perfect. As I kind of go through this, a lot of you will naturally think, well, did you account for this factor or that factor? And you're probably right. You're probably correct. There are a lot of things that we could have accounted for. It's a very, very difficult data set to get. I'm sure if I asked each one of you to kind of turn to the person next to you and say how much you got paid, you'd probably be pretty reluctant to do so. So that's why it's such a difficult data set. So what did we do? We took a single country, which is the United States. We took the very, very top of the pyramid. Somebody just walked out. Oh my goodness. Just kidding. Top of the pyramids, it's more likely to be competitive, we thought, or we hoped, and it's more likely to be a meritocracy, right? If you're dealing with kind of stakes that high, we were hoping that perhaps we would see a little bit less of an imbalance. But the main reason we did that is that there's just quite simply more data. So this is kind of the approach that we took. This is a screenshot. I'm sure a lot of you have seen kind of Dataiku at the demo stations and things. So we did the whole project in Dataiku, and the approach that we took kind of looked like that. That was our flow at the end of it. So you can see the different kind of sections that we went through. First, we had to get the data, prepare it, do a little bit of analysis on it, a little bit of machine learning. We were trying to see if, with the numbers that we do have, could we predict and fill in the salaries that we don't have? And then we kind of drew a couple of charts from it, and I'll kind of walk through those a little bit towards the end. So the way that we got the data, and this is kind of how the whole project started actually. So we actually set out, my colleague Alex and I, we set out to do a little bit of kind of, could we beat the market, beat the stock market in a way? Obviously you can't, but we figured it'd be fun to try. So what we were doing is we were looking at IEX, which is a kind of online stock exchange where you can pull kind of ticker data. So data about, different big stocks in the US. So we looked at the IEX, and as we were doing that, we were going to Yahoo, and we saw like little tables like this on all the pages that we were looking at. This wasn't what we were looking for, but we noticed that every stock that we checked had one of these. And what that is it's just a list of key executives. So there's a couple different things here. We have the name with, crucially, the title. Is that a title? Mr. and Mrs.? Yeah. Then we have the job title, and then we have the pay and the exercise pay. So you might get paid $10 million, but for one reason or another, you might only exercise 8 million of that. And then we have the year that people were born in. So not all of this information is disclosed. Some people disclose their pay, some don't. Some keep their birth date undisclosed, etc. So already this is kind of patchy, but it's a good data set to start with. So that's where we started from. So just a couple of caveats about the data. Full set of IEX listed companies, so we took every single one that we could find. Not all the execs published their salaries. We used the pay column, not the exercise pay. Again, that's another factor of, we could account for different things or different variables, but we just wanted to get rid of all the bias. And then there were two main challenges that we had coming from like a kind of data science standpoint. First, we had to normalize people's job titles. So you can see that this person here is listed as a CEO and executive chairman. People's job titles change. People get multiple job titles or sometimes like one-shot job titles that nobody else has. So we kind of had to normalize that. And then we had to normalize pay. So some people listed in millions, some in billions. Seems like a small thing, but you don't want to make silly mistakes like that. So those are two of the challenges. The other big challenge is determining people's gender, which probably seems like a very simple problem on the face of it, but it's not actually that much of a given, right? People's names are not always, kind of gender specific. Different cultures have different names, which mean different things. So the best way that we could kind of think to do that, and again, this is imperfect, was we took a massive data set of kind of names and genders, which took as much data as we could find, basically. And then we cross-referenced that to make a determination. And the challenges here were that we had a lot of different permutations and origins of the names, and we could have done something around NLP, so natural language processing, but we figured let's just go like this for now and see what we can come up with. So first thing we did then, we did some sanity checks on the data. So this is kind of the broad distribution of the sectors, the industries that we were looking at. And bear in mind, this is like all of the IEX listed companies. So this looks like pretty much okay, right? This is good, kind of what we'd expect. A lot of financial services and healthcare kind of leveling out towards the kind of less common big listed companies. So all good at this point. This is the data set that we were then working with, that we were then going to start analyzing. So we had about 6,500 different companies, different stocks. We had 46,000 first names in our kind of database of our lookup database, male, female, and then we cross-referenced that against about 20,000 key execs of like individuals. When we were then going to do the machine learning and start trying to predict people's salaries, it is very, very difficult for an algorithm to start predicting numbers that are, between a range of 1 and like, what is that, 5 million, 500 million? Those are very, very like large numbers. So we decided that we would take the log of the salary distribution and then take it to the power of 10 to get back to the salary prediction. It's a lot easier for a model to predict something between like 4 and 12 than between 0 and 50 million. It's just too much variance. So we cut that down and we took the log. The model that we used, XGBoost, we trained a couple different ones. Random forest against XGBoost. That one performed the highest for the metric that we were looking for. We got a MAPI of about 3.5, which is pretty good for the most part. And just looking at the logs of the salaries. So up to here, all good. Then, this is when we start kind of going into what we're actually seeing in the data once we started like really exploring it, now that we're sure that we have a pretty good kind of baseline to start going from. So, variable importance. So what this means is like the variables inside my data that are kind of moving the needle the most. And it's kind of what you would expect. If I have a lot of employees in my company, my pay is generally going to be higher than somebody who's looking after fewer employees. Cool. Age. There, I think what we're actually seeing is not necessarily age, but more kind of years of experience, presumably. And then we start seeing the titles. So CEO, chairman. There's a couple of outliers in there, like industry, biotech. Interesting. But for the most part, that's a good kind of sanity check as well, that we're, to this point, on the right track before we start kind of pulling out some interesting metrics. So, put it on a scatter plot. The map here looks pretty good. We're getting a pretty good distribution. And then, this is the hypothesis that we were hoping to come to. So this is the hypothesis that we really wanted to test. So we were thinking, okay, if we're looking at the very, very top of the workforce, if people are talented and working at the very top, you're more likely to be picked up, right? Irrespective if you're a man or a woman, if you're, I don't know, Apple and you want a new CEO, you will just go find the best person for that job, irrespective of gender, and pay them what they deserve. That's what we're hoping. More data, more transparency. So if you can see what your colleagues earn, and we see this from countries like Sweden, for example, where they publish all the salaries, they have a smaller gender pay gap. That's what we were hoping to see as well at the top. And then we were hoping that publicly listed companies would have more accountability. So they have shareholders, they have people they're accountable to. So we were hoping that we would see less bias. And yeah, more competition, more freedom to move. If you're like a high-flying exec and you want to leave and go somewhere else, you can probably do that. There's more kind of job mobility up there, presumably. That's our hypothesis. So let's see where we got to. So first of all, when we start digging into these charts, we're looking at title and age. So where's the wealth going? Here we're seeing the age, and this is the sum, by the way, so it doesn't necessarily mean that when you're above 60, your pay drops off. It's just that there's probably fewer people in that bracket. But essentially, if you're kind of, between 50 and 60, that's when people are like really, really earning the big bucks from the ones that we were seeing. So kind of what you'd expect going up there. Where the wealth is going, and here we're kind of splitting it out by job title. CEO, as you'd expect, earns considerably more than the rest of the roles. General counsel, CFO, etc. Kind of what we'd expect so far. This is where it starts to look a little bit less cool. So of the 20,000 odd names that we started with at the beginning, that's the distribution between male and female. So 12% are female and the rest are male, which is somewhat depressing reading. It kind of gets worse when you take the same pie chart, but you're looking not at head count, but at salary. And the discrepancy is even more up there. So it's 92% of that 10 billion total pay is actually going to males, and only 8% to females, which is even less than the head count. So that's not so cool. So where's the money going in terms of males and females plotted together on the same graph and broken out by job title? So this, for the most part, looks, not so bad. There's about maybe a 10-15% gap for most of the roles. Chairman is an outlier there. So we saw more money actually being paid to female chairmen than to men as a sum. So there's a couple of like very, very high paid female chairmen, so that's cool. For the rest then, going down, CEO, president, COO, those are broadly similar. CIO, big discrepancy. I can't really explain why. It's an interesting one. But the really, really interesting thing, like the dev, pretty kind of common ones, but there's this one category right here called others, and that isn't a category that we just didn't really know what we were looking at. That's a category that we created. The reason we created this others category is this is when we couldn't really make a determination and put those jobs into a box, right? So I originally studied law at uni, and I wrote my dissertation on an interesting topic, which the EU was looking at legislation at the time of should we enforce a minimum number of women on boards. And I actually started my essay and I thought, yeah, absolutely, we should do that. That's a great idea, like it should be even. The more I explored it, of course, then I realized actually it's a terrible idea. If you are someone who has worked your whole life and you finally are about to be promoted to the board and the EU passed this law, you risk kind of becoming that just token woman. People will lose respect. There's a whole lot of different reasons why it's a problem that has to be fixed in very different ways, right? It's not a quick fix like that. So this others category, these are titles that you wouldn't necessarily find on a board, right? They're titles that are kind of one shot, a little bit weird, and we're kind of worried that they are just titles that are almost token titles that you wouldn't necessarily find in other companies. They might not be, but that's where you see like a really, really big discrepancy. So it's, you know, it could be somewhat of a worry, but it was interesting that we found that. Essentially, this one I really didn't like, the HR being kind of the most similar one. It's very kind of cliche. Otherwise, the men are kind of listed in light blue there, the women in blue. But, you know, it continues being not so nice to look at. And, you know, at this point, we're kind of doubting our hypothesis and thinking, you know, what if we actually looked at the data beyond this top 1%? Like, this is probably even worse. This is something that really should be talked about. Looking at it by age range, we are looking here at kind of 25 to 40 for these, and then, you know, 45 to 60. And it actually looks like it's getting, well, yes, it actually looks like it's increasing. If you look at it the other way, does it look like it's decreasing? Possibly. What's going to happen when this bracket in the kind of younger side of the graph move up? Is that also going to increase again? We don't really know, but hopefully not. But, you know, we're possibly looking at a generational thing. We're possibly looking at a seniority thing. We're not really sure. But these are all things that are not necessarily going to change unless people start, you know, really talking about them, really discussing them and asking these questions. The last thing that we saw, which is the only kind of discrepancy, the only kind of outlier, is that if you are a woman who has a doctorate, and dark blue is the female, male is on the right, you actually earn more. So that is the only one that we found that is not explainable by some kind of weird tweak in the data. That's the only kind of positive that we found. So if you have a PhD and you're up in that top 1%, you are probably more likely to earn more than a man. The only good thing that we kind of found. But really, it's really just about kind of speaking about it. It's a problem that we had a lot of fun kind of diving into, and I wish I had a solution. I don't, but at least we can kind of talk about it. So thanks for listening.